Video, I'm gonna literally walk you through every step that I went through to create 256 unique NFT images, and how I'm gonna do it again for over 2,000 NFTs. In fact, every month in 2022, I'm gonna be sending the members of Whiteboard Crypto Club their very own unique cyborg NFT, but more about that later. Generative art is a relatively new term, and to break it down really simply, it means instead of creating 256 different pieces of art all manually or by hand, I create 256 pieces of art by using code to mush together a bunch of pieces. In fact, the only art that was actually created was around 16 to 20 unique assets that were all mushed together with code. I'm getting ahead of myself already, as I didn't create any piece of art. All the credits go to this wonderful artist Javakir, who's been on our team since the very beginning of Whiteboard Crypto. So, using code, we can algorithmically put together combinations of digital assets to create unique images. For example, let's say there's 2 dogs and 2 hats. We can have dog 1 with hat 1, dog 1 with hat 2, dog 2 with hat 1, and dog 2 with hat 2. If you really scale this up, you can create a wide array of art simply by creating a small number of initial assets. So for our turtle NFT examples, we created 4 variations of 4 things. So 4 different backgrounds, 4 different bodies, 4 tools, and 4 face features. By multiplying these together, you can see that 4 times 4 times 4 times 4 comes out to 256 different images. If we add another set of 4 things, we can easily get to over 1,000 images, and it only grows from there. Next, let's get into an overview of NFTs, just in case you're not completely familiar with how they work. So an NFT is simply a token that's unique. So to be more specific, it's literally just a token. It's not a picture, it's not a piece of music, it's not anything else. It's literally a token with an identifier. We can make it represent a picture by coding something into that token and saying, this token represents the image that is hosted at whiteboardcrypto.com/turtles/0.png. But without that hosted image, the NFT itself has no other data. It's literally just a pointer. To make it very clear, NFTs are simply tokens that point to other things. We can make them point to art, or car titles, or music clips, or even just a URL. But in the essence, the NFT is simply a token pointing to something else. This means if we own what it points to, technically we could change it at any point, and I'll get into that in a little bit. Before we get too far, I wanted to share about our very own Whiteboard Crypto Club, which is a paid membership where you get access to step-by-step walkthroughs on how to do things in the world of DeFi, specifically things that people all around the world use to make money. Along with signing up, I am personally sending each member $20 of Ethereum, and every month that you're a member, you'll get access to that month's NFTs. Now, here's where it gets cool. To promote learning, and we have a ton of learning incentives in the club, last month I put $1,500 into a crypto wallet. I took the private key to that wallet and hid it in all 256 Turtle Cyborg NFTs, so that way everyone would have a chance to find it. Eventually, one of our club members found it and won the $1,500 that was in the wallet. Now you might be wondering, what was the puzzle? Well, the puzzle was really simple. There were 256 NFTs, so in each turtle, I made their eyes either blue or red, and these represented zeros and ones. You can go through all 256 NFTs, and you get a huge list of ones and zeros, which are all technically binary numbers. You pop those binary digits into a converter to go from binary numbers to hexadecimal numbers, and bam, you have 64 characters that are the exact private key where I hid $1,500. Here's the kicker though, this month I'm hiding over $10,000 in 8 different puzzles. Some are easy and some will be difficult, but everyone will have access to solve these puzzles and redeem the money. This is a part where I say that club members get an advantage, meaning hints, because they are technically responsible for me being able to give away such a large prize amount. But I do plan on sharing the solutions once they're solved, so that everyone can learn cryptographic ideas and concepts too. Without too much further teasing, let's get into how to generate some art and turn it into an NFT. The first step is to plan and create a bunch of image assets that you can merge together. You have to be very organized about this, as each set of images must look good on top of each other. You can think about this the way that Photoshop layers work, with each layer being any variation that you want to add. Our artist Javakir created these with that in mind, so they worked perfectly for our next step. The next step is to use any program to merge all of these together. Now, I'm a big fan of Python as it's quite easy for beginners to learn, and it's also super fast to bug test with. If you want, you can copy my code, and maybe I'll put it in the description below. I'm going to explain how these things work, but if you're already familiar with code, you can probably skip this part. Now, the first bit of code is importing a bunch of code that someone else wrote, so we don't have to start all from scratch. The next bunch of code blocks is a bunch of code creating something called an array. Now you can think of an array as simply a list. Even though some professionals may get upset at me for saying that, it basically holds a bunch of data in a specific order. In each of these groups, we are adding the directory file of each of our images. This way in the code later, we can do what is called a loop through this array to get each one of these images. After we've initialized all those variables, the next step is to create a counter. Now this is just a number starting at 0 and that we will use later for naming our images. The next step is where it starts to get a little more complicated. We're going to create something called a function, which is a fancy thing where we give it some data and then it will automatically do something with all that data. Now functions are really useful when you want to do one simple thing a bunch of times without just copying the code a million times. In this function, we're going to give it a bunch of numbers called A, B, C, D, E, and F, and we're also going to give it counter. Next, we're going to create a set of variables. You can see here that each variable is referencing a specific group, and then the brackets means which part of the group to pick out and use. Using this function, we are going to be giving each of these groups different numbers each time, so they'll be selecting different parts for every image. Finally, this is a bunch of technical code that's difficult to explain how it works in a video like this, but it's basically going to be taking the first layer and then adding the second layer to it. And then it's going to be taking the third layer and adding it to the previous merge, and then adding the fourth layer, and so on. And then at the end of this code, we're going to save and name our image whatever the counter is at. Finally, now that that simple function is created, we just have to call it like 2048 times. This is another part that's a little confusing, but these are basically just a bunch of loops. Loops are something that will run the code inside of them a bunch of times. They will create a variable that automatically increases each time also, so the first time, f will be 0, because Python counters like this start at 0. Then the next time it runs, it'll be f equals 1, and then it'll stop. However, the loop above it will actually be running 4 times, so 0, then 1, then 2, then 3. You add all of these up, and you get a big loop with variables that go from 0000000 to 000001, then to 000010, then to 000011, and then it keeps counting like that. This allows us to go through all 2048 variations. Inside this loop, we will call our master function that we created earlier and give it all of the variables that it needs. So A, B, C, D, E, F, and then the counter. When this function is done, we're simply going to increase the counter by one number and then go on to the next step in the loop until it's done with all of them. Now this is the Generative Art code, and it's kind of complicated if you have no coding knowledge. But if you do, well, you probably already see some ways to do it better than I am. I'm by no means a master coder, but what I love about Python is that you can play around with it until it actually does whatever you want it to do. That's what I like about coding. It doesn't necessarily have to be perfect, it just has to be functional for me. We can check our folder and look at all the images to make sure that they were created. And for this example, they all look good. So now it's time to move on to our next step. Now, we simply have to move all of our images to an online server so that we can point to them. I'm personally going to be using whiteboardcrypto.com because it's easy and there's no need of setting up a dedicated server for this. Personally, I know that I have plans to own and host whiteboardcrypto.com for a very long time, but if you wanted this to be even more permanent, you could use a blockchain protocol called IPFS. IPFS stands for Interplanetary File Storage, and is a way for you to host things in a decentralized manner for free. I'll probably add a tutorial on how to actually use IPFS in the club, but it's way too many steps for this video, and isn't for beginners that may be watching. So now we have our image hosted on the web so that anyone can see them, and soon we'll be setting up the smart contract, but the next step is to create something called a metadata server. Now this is a necessary step, but what it does is allows you to create that pointer. So basically you create the NFT, and the NFT says, we point to this thing. Well, that thing is our metadata server, and the metadata server will give us all the information we need about the NFT, including the title, the description, and most importantly, the image URL. I'm going to show the code on this server real quick, but I do not have time to explain it in this video. In fact, it probably deserves an entire video. So whenever you go to whiteboardcyborgs.com/elephants?ID equals, and then pop whatever number you want in there, it'll automatically give you information about that NFT. This is how easy it is to set up a metadata server. Now, when we import to OpenC later, this is where the information will come from. Alright, now it's time to get into the actual smart contract code. You can see here this is on a website called remix.ethereum.org. So this is actually an Ethereum website, and this is what we call an IDE and basically compiler. So instead of using like software that I download, you can actually do this in your browser. So we have a bunch of imports here, which import is basically a term for using someone else's code. You can see here we call the contract Whiteboard Elephant, and then I don't really have the time to explain all of these in this video since it's already kind of long enough, but the main thing you need to focus on is down here we have this function called mint, and what it is, we give it this address. We actually give it an entire list of addresses, and then there's a bunch of like things that need to happen for this thing to actually run. And then what I've written down here is actually a for loop, so it'll go through the list, each and every item, and it'll do these things. And then when it's done that thing, it'll go to the next item. That's what this I++ means. The first thing is to mint the actual NFT and then send it to the first thing in our list. And then as I increases, so I will start at 0, it'll run through this code, and then it'll increase it. And then it'll run through this code again, and it'll increase it again. It'll run through, and it'll keep doing that until it's hit every item on the list that I give it. And that's pretty much the main thing. Here's the rest of the code. Usually smart contract code is actually very simple. You just have to be very careful not to make a mistake, otherwise you create a vulnerability. And you have to be mindful of those things when you're coding a smart contract. So the first thing we're going to do here is we're going to go over here to this compile tab. And personally, I'm going to use 0.8.7. I'm going to go ahead and click compile. And this will actually compile our code so that the program can actually be read. I'm going to change contract to Whiteboard Elephant. And now that it's compiled, I can actually deploy it. So I'm going to go click on this button right here, and I'm going to change it from JavaScript VM London to Injected Web 3. And this allows us to use MetaMask with our actual smart contract. So you can see here we've got 0xA58 selected for the account, and that's actually not the one I want to use. I want to use this one that ends in 82D1. So I'm going to go ahead and connect it. 128 Matic, and that's how I was able to tell. The account has 128 Matic. So that's the account we want to use. I'm not going to mess with gas limit or the value, but I am going to change the contract. So the one we want to use is the one that we coded called Whiteboard Elephant. And then the next thing that we do is we click this drop down here, and then we fill this out with data that we want to put in the smart contract. This base token URI right here, this is actually what is going to be the metadata server. So we're going to select all of this, copy it, except for the 0, because we're actually going to be changing the 0 to go 0, 1, 2, 3. And as you can see, if I change this to 2, it updates all these numbers. It gives us new data. So I'm going to copy this, go back to Remix, and paste it in. The mint price, this is how much it costs to mint. The max price, and then the wallet and the admin are going to be our own addresses. And now that everything's filled out, I'm going to go ahead and click the transact button. And it's going to cost me a little more than 1/10 of a Matic. So I'm going to go ahead and confirm that. Alright, now we have actually deployed our very own first smart contract. So if we go over here, click these 3 dots, and we click View Account in Explorer, you can actually see this one is 26 minutes ago. We may have to wait around for a little bit for it to show up on this Explorer. There we go. 31 seconds ago, this transaction has been approved. So I'm going to go ahead and click on it. And you can see here it's actually a contract creation. So this is our account 38 seconds ago. If we click on this right here, you can see that we have actually minted our very own first smart contract. Now let's go back to the Remix, and we're actually going to start minting some NFTs. So the first thing we're going to do is down here on deployed contracts, we're going to go ahead and click this drop down arrow. And then we're going to set mint. We have to set both of these to true. And this allows us to actually mint. What this does is basically allow us to turn minting on and off. So I'm going to go ahead and confirm this transaction. And that was confirmed. So now we can go up here to this mint option and give it a list of addresses to mint to. Now I have actually pulled these up from the current Whiteboard Crypto Club members, and I'm going to send it to them. But first we have to parse some data. It has to be in this format where it's an open bracket, a quote, and then the Ethereum address, and then a quote, comma, quote, and it has to be like that through the entire thing. And I have to parse it a little bit more because some of the members didn't follow instructions. We've got some spaces in here. Sometimes I've got ENS domains or unstoppable domains I have to change. But this actually looks good right now, so I'm going to move this just to see if any more errors pop up, and that actually was a good thing I did that. You can see they show up. That's actually really cool how it shows up like almost perfect. Ah, there we go. That's nice. For some reason, this address right here is shorter than it should be. So I'm just going to remove it. Everything shows up nice and clean. So I'm going to copy this, and then I'm literally just going to paste it right here in the to send address. We're going to click the transact button, and this should send it to around 127 different addresses. It's going to cost half a Matic. I'm going to click the confirm button. Ah, that's good coffee. Sometimes it takes a while, and I'm just going to bump this number up to make it go a little faster. Alright, it said that actually failed, but I don't think it did. And just to make sure I don't actually send them 2 NFTs, I'm going to check the blockchain. So I'm going to go ahead and close both these tabs because I don't need them. And you can actually see here where we created the contract, and then we made it so that we can actually mint them. And then if we wait a little bit, we'll see if that transaction pops up. After 10 minutes, if it doesn't pop up, then it means it truly did fail. But I can still see it pending here, so I don't think it necessarily failed. And we're going to wait and see if it fixes it. There we go. 30 seconds ago, we have this transaction that is named Mint. So I'm going to go ahead and click on this and see what's inside. You can see here the transaction action is actually that we're minting Whiteboard Elephant tokens and giving them to a bunch of different people. So if we go to this contract, we should be able to see a bunch of interesting data. You can see here the token tracker. If we click on this, it should be, we actually sent it to 128 different addresses. And you can see every individual mint. It's being minted from pretty much nothing into their account, which that's fine because we're minting new tokens anyways. So now I just have to repeat this process for like 1,800 other members. Alright, that should be all of them. I think it may take a couple more minutes for this page to actually update, but they should all be on the blockchain. The next step is to go over to OpenC, and then we're going to go to my account here, which I don't know if I'm logged in the right one, so I'm going to go ahead and log out. I'm going to make sure that I'm in the right account. It should be Whiteboard NFTs. We are there, and now I'm going to click here to go to my profile and make sure that they match. So 0x97B0, 97B0, and you can see that I bought one. So the next step is going to be going over here to my collections, and then we're basically going to be clicking on this button right here and import an existing smart contract. Now OpenC is really smart. It looks like they've already found it, but I'm going to go ahead and import this and show you how to do it if they don't automatically find it. So we're going to click live on a mainnet, and we are actually on the Polygon mainnet. So we're going to go back over to our actual contract of Whiteboard Elephant. And the way you find this is any transaction where like you're sent something. So if you ever sent this and it's to your address, you click on Whiteboard Elephant right here. You just click on it. And then it shows you how many elephants there are and holders, which this actually needs to update. It updates like every 10 minutes, I think. And then what we're going to do is this contract right here. We're going to click on it. And then this right here, this 0x4a, this is the actual contract address of the NFT. So I'm going to go ahead and copy this. I'm going to go back over here and paste it. And now that I've done that, I'm just going to click the submit button, and it actually updates and then takes us to our NFTs. And here you can see all of the successful elephant NFTs are sent out. And if I click on one here, it should be sent to a different owner. So this one is owned by 4AAD. And then if we go to a different elephant, how about this one? It should be different. So this is a different person that owns this account. And you can see they were minted around 23 minutes ago. So that's how you actually set up your very own NFT through Generative Art and then upload to OpenC. And now you can obviously click on this little edit thing here. This little transaction is actually saying, hey, I'm actually the owner of this collection. And that's why we had to put our addresses in the smart contract. But here I can actually add logo images. I can change the name. I can change the URL, the description. I can even put links to like the website and the Discord. And I could even set up a royalty. So whenever someone sells one elephant to another person, I could get 10% of that transaction. The last thing on here is that I can actually change which tokens that people pay with. So this is a really cool feature, and I'm going to mess with this later, but I wanted to show you guys how simple it was to create generative NFT art and then upload it to OpenC using a smart contract. I'll also mention I did all of this on Polygon, so it took around like $20 to $40 to mint all these NFTs. If I did it on Ethereum, I can guarantee you it would be more than $10,000. Honestly, a year ago, I would not believe it if you told me that I would be writing smart contracts and creating generative art. So the feeling for doing this the first time, and then the second time, and then finally like the 15th time when I actually got it working was exhilarating. Unfortunately, anything past this step is something you'll have to be really creative about. Marketing NFTs is an entirely new field, since pretty much the only selling point that you can claim is they'll be worth more than what you bought one day. Now there are utility NFTs, and there are even some royalty sharing NFTs being created, but if you're doing it for fun, it's going to be hard with a sea of other NFT artists out there trying to compete with a product that was free to create and doesn't really offer too much to the customer. I may do some research on the largest selling NFTs and just see what they did to market their projects, but you'll have to click the subscribe button and the like button if you want to see that video. Unfortunately, I have a feeling this will be one of those videos that takes a lot of work to create, but doesn't really get any views. Hopefully though, the people that do see this video love the work that I've put into it. If you did like this video, consider subscribing for more amazing videos, and if you thought it was cool to learn about this stuff in a step-by-step way, you're gonna absolutely love what's in Whiteboard Crypto Club. Our community is growing every day, and I'm so proud to see that it's such a welcoming and positive community. If you're interested in joining, there's a link below that you can check out. It's technically the most affordable crypto course/community out there, so keep that in mind if you're wanting to invest in your own crypto education. Anyways, I've shilled our awesome projects too much. I hope that you enjoyed this video. I really hope that maybe you've learned something, and most of all, I hope to see you in our future videos.